Hello everyone. Welcome to the web learning series. In this presentation, we are going to see the parallel in serial out shift registers. Not all devices in the system work entirely as parallel only or in serial only mode. For instance, the communication inside the computer uses parallel buses that transmit parallel data from component to component. However, the communications among external devices takes place using serial data. So, parallel in serial out shift registers are required. In parallel in serial out, the data is loaded into the register in a parallel format. Then, this data is outputted one bit at a time on each clock cycle in a serial format. In serial communication, each bit of the message is sent to the receiver one bit at a time. Serial communication requires less wires and less complex electronics. Example, USB. In parallel communication, data transmitted in parallel, so it transmits at a faster rate. In this presentation, let us see how the data is parallelly loaded and then shifted serially on each clock pulse. When the control input shift is 0, the load becomes 1. This 0 value from the shift input will be given to one of the inputs of red color AND gates. So, the outputs of all the AND gates become 0. Whereas, one of the inputs of AND gates X1, X2 and X3 receive the signals from the load which is logic 1. The second input of these AND gates are B, C and D. These signal now reaches to the inputs of second, third and fourth flip-flops through OR gates. The first flip-flop input is directly connected. Here you can see the load mode operation. Similarly, when the shift is 1, the shift operations will be performed. Now for each positive edge of the clock pulse, one bit will be shifted towards right. In this presentation, the input of 1101 is shifted towards right for the first clock pulse. Here you can see the parallel load as well as the shifting performance for one clock pulse. In the same way, the shifting operation is performed for 4 clock pulses as given in the table.